Okay, kids, last section, chapter 7, I told you. Here we go. Oops. All right, here we go. Guys, properties of two more quadrilaterals. We've got to look at some things about trapezoids and kites that we call them. And this is really simple today. All right, so this won't take too terribly long to get through, I don't think. I think that the definitions are what they are. I think you'll kind of know what it is. There's some things that we need to look at theorem-wise that are going to pop up and may not necessarily know them, but it's going to help us finish up this section. So, with 7.5 being titled Properties of Trapezoids and Kites, what question are we trying to answer here? Volunteer to read that for me?
What are some properties of trapezoids and kites?
What are some properties of trapezoids and kites? Okay, so in order to answer that, we're going to use properties of trapezoids. We're going to use the trapezoid mid-segment theorem to find distances. We're going to look at properties of kites and identify some quadrilaterals. So first things first, kids, we need to know some things. What's trapezoid?
It's a quadrilateral with exactly one pair of parallel sides.
One pair of parallel sides. So it's going to look like this. Well, maybe. Slap a Ford sticker on my pen today. It's not working. That's a war now? Well, don't worry. I'm pulling for a Ford tonight in the qualifying races. So I like the driver. I know. I'm really going against my beliefs here. That's trapezoid because it has how many pairs of parallel sides?
Like two.
Well, two sides are parallel, which means that would be how many pairs then? It used to be one pair. Okay? All right. A trapezoid might also look like this as well. It might be that the top and the bottom aren't parallel, but it might be that the left side and the right side are parallel. So you know what a trapezoid is, right? Okay, bases. The bases are going to be then the two sides that are what in a trapezoid? Parallel, okay? Base angles. Volunteer to read base angles for me. Roll with it, bud.
Base angles of a trapezoid are two consecutive angles whose common side is a base. A trapezoid has two pairs of angles. For example, in trapezoid ABCD, angle A and angle D are one pair of base angles, and angle B and angle C are the second pair.
Okay, so I'm going to do this quickly. I'm going to draw a trapezoid like so. You should do the same. Okay, there's a trapezoid. Okay, I'm going to label this trapezoid A, B, C, and D. Okay. Label your trapezoid A, B, C, D like that. Okay. Okay, you guys agree that B, C, and A, D are parallel? Okay, so I'm just going to do this right here. It says a trapezoid has two pairs of what? Okay, in this case right here, A and D are one pair. So I'm just going to, I don't know what to do. I'm just going to kind of circle angle A and angle D down here as base angles. I don't want to do it that way. How about I do it this way? I'm going to say A and D go together because they're the angles at one parallel side. Aren't they the angles at the same parallel side? And then what's another pair of base angles up there that
B and C.
B and C would match up here. B and C would be base angles together. So if I say B is a base angle, then what's the other base angle we're going to talk about relative to B? C. They have to be on the same side of the parallel. Okay? All right, the legs in a trapezoid, the legs are simply the what?
Non-parallel sides of
Okay, so how many legs will a trapezoid have typically? Two. It's the two sides that aren't parallel. Okay. Isosceles trapezoid happens if the legs of a trapezoid are what? So let me draw my best isosceles trapezoid. Maybe. Come on. Okay, isosceles if it's a trapezoid first. So in order for it to be a trapezoid, top and the bottom in this case would have to be what? Isosceles trapezoids occur if it's a trapezoid and the legs are what? So if I put a tick mark here on this leg and a tick mark on that leg, then it is called an isosceles trapezoid. Okay? Exactly. All right, then the one that's going to be, it's not new because we looked at mid-segments of triangles, but we're going to look at mid-segments of trapezoids. It says the mid-segment of a trapezoid is a segment that connects the midpoints of its what? So as an example, let's change up some colors here.
Maybe red.
Change the colors and I can't draw a trapezoid. Okay, there's trapezoid, kids. You like it? Okay, mid-segment would be this. If I have a midpoint here and a midpoint here. Now again, the midpoint occurs on the what? Okay. The mid-segment is going to be that line then that connects from here to there. Okay. I have a question. If the top of this trapezoid length, if the top base is 10, the bottom base is 20, anybody want to guess what the mid-segment length might be? If the top was 10 and the bottom was 20, anybody want to guess what the mid-segment length might be?
15.
It's going to turn out to be the average of the top and the bottom, or the two parallel sides. All right, and we'll talk about that. Okay. And then the last thing we have is kite. And I'm not telling you to go fly a kite because it's too cold today.
Are you sure?
I would have told you on Tuesday when it was really windy. Okay. A kite is a what first?
Quadrilateral.
That has two pair of.
Consecutive. Congruent sides.
Okay, I'll do my best to draw this, and I'm going to struggle with it. So don't laugh at my art. Okay. No laughing allowed. Ah. Ah. Kind of like that. Do you guys see my kite? Okay, what it says is this. It's a quadrilateral when you have two pairs of consecutive congruent sides, meaning this side and this side. Not opposite sides anymore. They are what? And then these two sides right here would also be congruent. Okay? So that's what you have for your kite there. All right? So I think we know what these shapes are. I think you understand what the definitions and the terms that come along with these shapes mean. So let's get into some of the things and some of the properties that come along or exist as characteristics with this stuff. Previous knowledge, you guys remember what a diagonal is. Segment connecting two consecutive angles. And you know what a parallelogram is, so I don't need to do that. So let me blow this up. Example 1. Take a look at here, kids. Identifying a trapezoid in the what?
Coordinate plane.
Okay. And decide whether or not it's isosceles. Okay, first of all, trapezoid. Definition again, please. What's the definition of my trapezoid?
A trapezoid is a quadrilateral with exactly one pair of parallel sides.
Okay. So I need to show whether it's a trapezoid first and decide whether it's isosceles. Well, as I look at the drawing right here, which sides appear to be parallel? Okay, let's look at the slope. Okay, let's look at the slope. So are you talking top and bottom as it relates to BC and AD?
Yes, sir.
So let's look at the slope from B to C. Here we go. You ready? Rise and run from B to C. Oh, it's Valentine's Day, so let's go. Huh? Or here. Huh? All right, what's the slope from C to B, kids? Negative 1/3. Okay, you guys agree? Okay, so I'm going to say the slope on BC equals 1/3. I'm sorry, negative 1/3. Guys agree? Now, if this is going to be a trapezoid, for sure, I can only show one pair of sides parallel. That means the other pair of sides would not be parallel. We're going to have to show that too, okay? What's the slope of this one here from A to D? How far down, kids? 2, and how far to the right? So the slope of AB is also negative 2 over 6, which is what? Okay, you guys buying what I'm selling so far?
Yep.
Now, those slopes are the same. Let's take a look at opposite slopes. Or the side of the slopes of the other side. How about this slope right here? From C to D. What's the rise? Help me, guys. What's the rise? So I'm actually going down 5 and over what? Down 5 over 1. You agree?
Yeah.
So wouldn't that slope be negative 5? Tell me what the slope from A to B is. Quick question. Take a look at these first two slopes right here. And these two slopes. What's true about the first pair of slopes? Same. What's true about this slope? They're different. How many pairs of parallel sides do you have? Okay, so I'm going to write down here that, first of all, we know it's a trapezoid. You know it's a trapezoid because we have how many pairs of parallel sides? 1 pair parallel sides. It is a trapezoid because there's 1 pair of parallel sides, right, guys? Good. Okay, pay attention for me, please. Now, I want us to know if it's isosceles. Okay? Isosceles means the legs would have to be what? They have to be the same, right? So, is this isosceles? Okay, first of all, do we understand why this is a trapezoid?
It has 2 parallel sides, and that's it.
Yep, 1 pair of parallel sides, right? Okay, is it isosceles? We would have to look at the left side and the right side distances. So the right side distance and the left side distance. We need to look at AB, and we need to look at CD as distance. Well, guys, go back to your slopes right here. For CD, we had a 5 and a 1, didn't we?
Yeah.
So wouldn't the distance for CD be the square root of 5 squared plus 1 squared using distance formula? What is 5 squared? 25. What's 1 squared?
1.
So the distance of CD is going to be the square root of what? 26, right? What values did we use for the slope in AB when we counted? So wouldn't the distance from AB be the square root of... What the heck's 4 squared? What the heck is 2 squared?
4.
16 and 4 are going to add up to what?
20.
Does root 20 equal root 26?
No.
These are not equal. Root 20 is not going to be equal to root 26. Those two legs are not going to be equal in length. Therefore, isosceles or not isosceles? No. This is not, okay, you are not isosceles. Get over it. Oh, I think I spelled that wrong, didn't I? There's another S in there, right? Not isosceles. Okay? Why is this not isosceles again?
Because they're not even square roots.
It's not meant to
Not
be.
isosceles because the
The
legs
sides are the same.
are
It's not meant to be.
not equal. Okay? They're not equal. All right? So keep that in mind. So if I want to show something's a trapezoid, how many pairs of sides do I have to show parallel? One pair. But I also have to show if the other pair is not parallel. Okay? And then check your leg lengths. If the legs match, isosceles. If the leg lengths do not match, then it's not isosceles. So some theorems here, kids. We're going to put a bunch of words into pictures. A lot of wordiness here. I think you'll understand it. Volunteer to read what the isosceles trapezoid base angle theorem is.
I got it.
Go ahead.
If a trapezoid is isosceles, then each pair of base angles is congruent. If trapezoid ABCD is isosceles, then angle A is equal to angle D, and D is equal to angle C.
So they're telling you that you have a trapezoid that's isosceles right off the bat. Draw this for me, please. Okay, isosceles, meaning the legs are what, kids? The same. This is what this theorem says. It says if I have this setup, isosceles trapezoid, then what this is telling you is this. If I label this A, B, C, D, this is telling you that the angles A and what are equal? This angle is equal to this angle, and then B would be congruent to C. That's what that theorem says. The isosceles trapezoid. You have an isosceles trapezoid, base angle theorem. I'm going to abbreviate this. ITMAT.
There's a lot of theorems that we have to remember.
I know. ITMAT. That sounds like a new company we should start. Let's start ITMAT. What are we selling?
Sounds like a game.
Imagine all the people
And game you went.
in their math that have to remember all this, like all the theorems like, in their brain. That's difficult.
Oh my god.
That's not even math. That's just like memorization skills.
Isosceles
Triangle.
base angle theorem. Okay? Well, there's a converse to that that says if you don't have an isosceles triangle, it says if this, it says this, it's the isosceles trapezoid base angle converse. What are you going to call this one? Hit back. All right, it says if a trapezoid has a pair of what?
If a trapezoid has a pair of congruent base angles,
So I'm going to draw a trapezoid. The assumption is you have what shape right off the bat?
trapezoid.
So it's saying, hey, we have a trapezoid. And if it's a trapezoid, what must be true about the top and the bottom, the way I'm drawing this? Parallel. Okay, let's label A, B, C, and D in here. This is saying if your angles are congruent, so in other words, if C and B are the same, and A and D are the same, what could you say about the two legs? Okay, the legs would have to be equal. Given that right there, your legs are equal. So in this case, which two sides would be equal then by that? You have a trapezoid with two pairs of base angles congruent. So which legs are going to equal, or which lengths will equal? Yeah, BA has to equal what? This would imply that BA is equal to what? I'm going to say so BA is congruent to CD right there. Okay? All right, isosceles trapezoid diagonals theorem. So start this one out as I, T, D, T. Okay, it sounds like another robot in. Sounds like another robot in Star Wars. ITDT.
What?
I don't watch movies.
Okay, here we go. Says a trapezoid is what? If and only if its diagonals are what? So in other words, trapezoid ABCD is isosceles if and only if AC is congruent to what? So here's what you have. They're saying, hey, here's a trapezoid. Here's a trapezoid. I didn't draw that very isosceles, did I?
Well, as long as you got the right lines on there, it doesn't matter.
Neil.
Yeah, we can't assume anything, Parson.
I know. I'm sorry.
Just with the lines.
I'm a loser math teacher.
I can't do math very well.
I'm a loser math teacher.
I quit. I'm throwing in the towel.
Just ask Donnie Trump Jr.
Did you sit on some water there, Chris?
I don't know what this is. I'm a little concerned. I'm getting older.
Yeah. Oh no. Yeah.
All right, let's just stop right there, okay?
Yeah, I was gonna say, is this being recorded?
Yeah, actually it is. And that's okay, all right? As long as we can laugh about it. Okay.
This one can come explain it.
Well, no, it's okay. I'd rather do that private, all right? So, okay. So it says a trapezoid is what? So they're saying you definitely have a trapezoid. And they're saying you have a trapezoid if AC and BD, those diagonals, if AC is equal to BD. So I'm going to put a tick mark in AC and a tick mark in BD. If those two diagonals are the same length, then what kind of trapezoid do you have?
Isosceles.
I have an isosceles trapezoid. So if this is true right here, kids, trapezoid ABCD with BC parallel to AD, and I tell you the diagonals are equal, what's that mean about the legs of this trapezoid?
They're equal.
So that would mean that AB would be congruent to what? AB would be congruent to CD. It means the legs would be congruent. That's what it means to have an isosceles trapezoid. Your legs have to be equal. Okay? All right. We're getting close here, kids. This is going to go pretty quickly now since we've gotten through these theorems. So let's run through this. Everybody have what they need, page 2?
Just a second.
Okay.
Yeah.
What is that? Snapple? Trust me. Okay. Alright, good.
All right, thanks, Nick. All right, here we go, page 3. So I want you to take a look at example number 2. Do it on your own, okay?
Is it sticky?
I don't know. It's like it feels like grease or something.
Oh, it's that kind. Oh no.
Yep, I can.
Uh-oh.
It's like such a weird spot to get sticky.
I know. That's the weird thing.
Maybe it's like on one of the side of your chairs.
Could be. I had a chocolate bar.
Oh, you probably sat on the table and there's something there.
What's on the table?
Let's search. It's always fun.
Yeah.
We were recording.
Well, that's what came out. So it's
Well, it's definitely not from the human.
I hope not. If it
Yeah,
is, maybe I'm a robot and they oiled it. All right. ITDT's struggling today. All right. Hey, ABCD is okay. So they're telling you what, kids? And what? Okay, so we got to find angle B, C, and D. Anybody have thoughts?
Yes.
What's one angle?
42.
Okay, which one is 42? Okay, angle D has to be 42 degrees because in an isosceles triangle, what's true about the base angles? They're the same. So how about B and C? Hey, these are still parallel up here, right? So in any situation where we have parallel lines, isn't this like a consecutive interior angle?
Yes, sir.
What would they have to add up to?
180.
It's 180 minus 42.
One.
So angle B would have to be what? 138, you say? Yep. So what's that make angle C, kids?
One. Oh, so you just add those two together, and then you subtract out 180, and boom, it's again. Oh, you add.
Now with a little bit of luck, 138, 42, 138, and 42 better add up to how much, kids? 360. Okay? Does it add up to 360?
Yeah.
Okay, so isosceles, trapezoid, base angles, both pairs will be the same. We have a pair of angles that are 42 degrees, and the other pair of angles is 138. Are we okay with that? Anybody struggle with that?
I'll do fine.
Are we on board at least?
Yes.
Roger's gonna go over.
What?
Good?
Yes.
Okay. Then example 3 talks about what?
Using the mixed segment of the trapezoid.
I'm not going to make this difficult on you. It says the mid-segment theorem. I'm going to call this a TMT. This sounds like a new wrestling club or something. TMZ almost, right? The mid-segment of a trapezoid is parallel to each what? Each base, and its length is 1/2 the sum of the lengths of the bases. If MM is the mid-segment of trapezoid ABCD, then MN is parallel to AB, MN is parallel to DC, and MN is half. This is a lot, okay? This is what this is saying. Let's get a picture for this. This is what this is saying. First of all, what do I have, kids?
Trapezoid.
Draw a trapezoid. I'm going to trick you here. Ah, shoot. There's my trapezoid, guys. You have it? Top and the bottom, parallel. My labels A, B, C, and D again. Okay, what this is saying is this. If I tell you that the midpoints of each side are here, M and N, mid-segment theorem tells me the following. This is saying that if you connect the midpoints of the legs, so which points am I going to connect to get my mid-segment?
BA?
No, midpoints of each leg. Which points am I connecting? M and? Okay, that's the mid-segment right there. All right? Now what this is saying, kids, is the following. It's saying, first of all, MN is going to be parallel to the top and bottom. Does that make sense?
Yes.
Then its length is the average of the two bases, okay? So I'm going to say this. I'm going to make a note right here. Mid-segment lengths is going to equal to base 1 plus base 2. The two sides that are what? Parallel. Divided by 2. It's going to be the average of them. I remember the example I used in the vocab. If I said the top is 10, the bottom is 20, what do you think the middle length is going to be? You said 15, right? Okay. So let's look at this right here. It says in diagram, MN, it says MN is the what? Okay, meaning that this is the mid-segment here. It says find the distance from what? Well, what's M to N parallel to? Well, PQ and what? All right, so how are you going to find this length from M to N, kids? Since this is the mid-segment, you would take the two parallel bases, which is 13.5 plus what?
18.9.
And divide that by what? I have no idea. 4, 19.4, 32.4, 16.2?
I'll get my calculator. It's on.
Only one of my eyes is ever watering. It's always this one.
16.2? Make sure you hit enter after you add.
16.2.
MN is
I
16.2.
lose faster. You lose, Allie.
Whoa, let's be nice.
Just like in health.
Oh.
Hey, you never even let us play Jeopardy, so we're fine.
Is he talking about beating you all the time?
Yeah.
Have him come run track with us on Monday.
Yeah, Josh.
I can't run. I can't run. I have a knee injury.
Okay, all right. You're on the disabled list. I'm sorry.
See, you make fun of a disabled person now.
Yeah,
That's
I
just
know.
wrong. Yeah.
Have you looked at yourself?
That's a free
Move forward. Okay, here we go. Using a mid-segment and a coordinate plane, find the length of the mid-segment and y to z. Okay? All right, this is kind of a toughie. Let's do this. Let's get this done. Well, we're in good shape. So we have to find the length of the mid-segment in this, kids. Okay? It's not too hard to do. What formula do I always use when we have to find a distance in the coordinate plane?
The distance
This formula. Okay? This is how this works. Well, they give us this and this right here, right? Aren't these the midpoints, kids? Aren't those the midpoints? So the distance of the mid-segment, we're trying to find the distance from what to what if I'm looking for the distance of the mid-segment. Trying to find what distance? Kids, stay with me, please. Stay with me. It says find the what?
Mid segment, YZ.
Is it YZ, my mid-segment right here?
Totally overpowered you.
Oh, looks like
Okay, here we go. Well, let's do this. Y to Z, how far over or down do I have to go to get the Y to Z?
Probably.
You count it. I can't see it. Looks like 1, 2, 3, 4. 4 units down, is that right? And then right 1, 2, 3, 4. So this is going to distance. Y to Z is going to equal, well, it's going to equal the square root of what plus what, kids? 4 squared plus what?
4 squared.
What's 4 squared and 4 squared?
That's 16, so 16 plus 16, is that 32?
Be the square root of 32. Now, I don't know how they want you to do this.
I'll sit this one out.
I don't know if they want you to simplify the square root. I'm just going to tell somebody to punch that in. Give me an approximation to 2 places.
I don't know if my calculator can do this, though. This could be rough.
Oh, your phone over there.
Where's the square root of that?
You should get 5.656.
5.6.
5.656. So about 5.66, is that right?
I tried so hard.
Okay.
Yeah, that's it.
She actually tries like
It's pretty simple, isn't it? In a coordinate plane, just find your rise, find your run, put them into the distance formula. Should be pretty easy, right? Okay. All right, well, we're moving on then. A couple more theorems. This starts to involve kites, kids. This is really pretty easy. I struggled to draw kites, but here we go. A couple more theorems. KDT is what we'll abbreviate this. And this one we'll call it KOAT. All right, here we go. If a quadrilateral is a what?
Kite.
Then its diagonals are.
Perpendicular.
So if quadrilateral ABCD is a kite, it says that AC is perpendicular to what? Okay, let me try and draw this as best I can. I'll do my best. Pretty good, right? Pretty good? All right, let's label my kite ABCD. I'm going to label it the same way they did down here. A, B, C, D. All right, if this is a kite, kids, if this is a kite, which distances are going to be the same? Well, give me a pair of sides that are equal.
The top ones on the side.
So, use vertices when you identify sides.
Oh, man.
What would AB equal? And what would CD equal?
DA.
Okay, so what this is saying is if you have diagonals in this, if you have any diagonals, the diagonal BD intersects CD in such a way that it forms what kind of angle? It's going to be 90 degrees everywhere in here. That's what that's saying right there. So if I have a kite, it's saying in any kite, the diagonals are what?
90.
Okay, so if I have a kite and you draw the diagonals, you can say, oh, that angle's 90 by kite diagonals theorem, or KDT. Okay. Next one here says the following. It says a quadrilateral again is a what? Kite. Then exactly one pair of opposite angles are congruent. So if quadrilateral ABCD is a what again? Kite, then BC is congruent to BA. And here's what this is getting at. Let me try to copy this.
Look for it. Oh my god, that's tough.
Okay, here's a kite again, kids. What this is saying is this. Okay, this is saying that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So if AB is equal to BC, which angles appear to look congruent? Could I fold B over to D? Would this have symmetry folding B over to D? Would it have symmetry folding A up to C though?
Yes.
Yeah, it would have horizontal symmetry there, which means that angle A would be congruent to, okay. What about, oops, I didn't want to do that. I wanted one arc in there. So A and C are going to be equal in angle, but what about B and D? Are they going to equal each other? Careful.
No.
No. Okay. So just the ones where A, the short side, they're right by the short sides typically. Okay. So let's talk here quickly. It says find angle measure in a kite. This is kind of tough. We need to find the measure of angle C. First of all, any four-sided figure will have how many degrees? 360, right? Okay, so if I have 360 degrees, how many degrees can I take out of this right now?
Half of that.
I can take 80 and 50 out, which would be taking out 100 and...
30.
Okay.
230.
So we have 230 degrees to work with. But what's going to be true about angle A and C here, since that's a kite and the way this is labeled? They're going to be the same. So what are you going to do with the 230 degrees that we need to split up evenly between angle A and C? Divide by 2. So angle A, angle C would equal how many degrees? Yeah, we have to take that 230 cut in half. So C is 115. If this is a kite like so, kids, what angle is A going to be?
115. Wow.
Okay. I'm going to send out an online here quickly. Want you again to be thinking, tomorrow looks like a work day. Monday will probably be a day to review. Tuesday's kind of looking like our chapter 7 test right now, okay? Let me send this out. Who's into big ideas right now? Yeah, why don't you get in there? Because we've got about 12 minutes left here. So I'm going to send this out. I'll make sure everybody has this.
I can't wait to watch the greatest showman in my business class.
It's not that great. I took that class, it's pretty easy, and yeah.
It's kind of weird.
Is it business?
I like Fishburger, so it's not weird.
Yeah.
I love Fishburger.
He gave me a gift card.
Yeah, you won.
Yeah.
Your Shark Tank.
I was an all-star.
What'd you do? What's the key to winning my coin?
Running fast. I ran back and forth with a Lego project. That's my product. Got $5 gift card.
The following students, please go to Ms. Leekham's room at this time.
Me.
Tyson Fleschner, Levi Gray, Jacob Lau, Ben Rempe, Mason Scott, and Carter Spore.
First thing I learned about.
Oh, hey. Still not there, folks.
I'm working on it, buddy.
Okay. Yeah. I thought it was my friend.